Okay, hey guys. So this one is my attempt to explain to you guys how you can predict the product of a Sharpless reagent. Okay, so first of all, if you're given this thing right here, we use the exact same problem that Dr. Nali brought up in class so that we are better at predicting the product and we have a way to verify it. So first off, you have to set it up. How do you set it up? First, you want to always draw your double bond as the horizontal line. Always, you always want to keep it horizontal, okay? And then draw the substituents. So on the left side, you have one ethyl group pointing up, and that ethyl group is anti to the hydroxide group on the other side. So I'm drawing them anti, and then pointing down on the left will be the phenol, right? Easy. Okay, setting up is right. You have one horizontal double bond, and then you should see now where your OH is. So you always want to keep your OH on the right, especially on the bottom right of the double bond. Okay, so now everything is set up for you. You are doing perfect. Okay, so double bond, horizontal, OH, lower corner of the right side. Okay, so if you expose this to the plus DET, then you just begin drawing everything again. And then you will have your epoxide forming to the top. So draw out that horizontal line that used to be your double bond, right? And then draw everything that's attached to it, including the OH and the phenol and the ethyl. And then the product for plus DET will just be this. Going up towards you, okay? While the product for negative DET will be the different one, will be the opposite one. So it will be this one where it forms downwards. It's going away from you. Okay, so the best way I use to memorize these is like, so plus sign. A plus sign means it's over zero, right? Or it's above zero, right? So I kind of subconsciously to just attach above zero with like above this little bond right here that used to be your double bond. And then as that said, just the negative is below zero or below the bond right here. So that's how you predict your products. Okay. This second one right here needs some further setting up because one thing we notice is that we don't have our double bond horizontal, right? And we actually need that for our setup. So how do we do it? Okay, we can rotate that thing. So if you choose to rotate that thing only by 90 degrees clockwise, you will end up with this thing, right? Where you have your OH on the right, but now it's on the top. It's not on the bottom, right? And then that's anti to an propyl group on the other side, the left side, right? So this is a 90-degree turn clockwise. You can choose to turn it further, or you can pancake flip it into this thing. Where now you have your double bond being horizontal and your OH being on the lower bottom, on the bottom right as well. So it just will be the same case like the last case we went through. You will be adding your epoxide the same way. But what if you keep your setup like this on the left, where you have your double bond horizontal, but then your OH is on the top right? Then now everything's a little bit different. Now, if you're exposing that on to plus DET, you will then see your epoxide being formed downwards, because now your OH is on the top right. And if you expose that same thing to negative DET, now it will be different. It will be forming to the top, right? So it's the exact opposite of the last case, where if you expose the horizontal double bond to and with the OH on the bottom, you will have the epoxide going up if that's plus, and then the epoxide going down if that's negative, right? But this is the opposite. So if you kind of pancake flip these molecules, you will see that it gives you the same products as you move on with this. So if you pancake flip this one right here, you have this. While now these two are going up, your OH is going down, and then your propyl is pointing up on the left side. Same thing here. If you pancake flip this thing on your left, you will have your epoxide pointing down, so OH on the right bottom and propyl on the left side pointing up. And that agrees with the product you might get if you flip it the way that would have your OH on the bottom and your horizontal double bond. Okay, so either way works.